So it's always going to be the bottom number divided into the top number, so it looks like this right here. The next section is converting decimals to fractions. To convert decimals to fractions, we need to be remembering the place value. All right, remember place value? Where we had tens, hundreds, thousands, and so on. So, for example, here if we have decimal 02. Let's change to my pen. Decimal 02. Well, this is the hundredths place. Remember that? So it basically means we have 2 out of 100. And then we reduce 1 over 50. So that's all that is, place value. If I had something like 0.25, it would be 25 over 100. It would be 1 over 4. Same kind of thing. Let's go to cruising through this stuff. The proper fraction to a ratio. Well, we already said that if we have something like this, we had 1, oops, back here. If we had 1 to 8, 1 to 8, we've always said that the 1 goes on top, 8 goes on the bottom. And that's it for that. Top number comes first, bottom number comes second. Like I show you right here, we have 4 and 31. 4 is on top, 31 on the bottom. And that's it. So, it says right there, first ratio number is always the numerator. Second one is always the denominator. Nice. Oops, come back. The next one says, it can be a little tricky. It says a mixed number to a ratio or ratio to a mixed number. First of all, the fraction is a mixed number. The mixed number must be converted into an improper fraction. I just want to see the next page. So, looks like this, see? If we have 1 3 over 4, remember how we do that? We would go 1 3 over 4. You take the 4, multiply by 1, and then add the 3. So 4 times 1 is 4, plus 3 gives us 7 over 4. And then writing that as a ratio, the top number comes first, bottom number comes second. And if we want to take that and convert it back into a mixed number, we just take the top number, first number, make it the top, and second number the bottom, and divide into it, same as we would convert. No big deal. All good? This is kind of more of a review of everything you've kind of gone through so much, so it's not a really big, heavy chapter. Decimal to a percent. We said move the decimal place 2 places to the right. That's the same as multiplying by 100. So I have 0.25. Move the decimal 2 places to the right. I get 25%. Percent to a decimal, it's just the opposite. We have 90. Move the decimal 2 places to the left. We get 0.9. The fraction to a percent, first of all, convert it to a decimal, then percent. So we have something like 1 over 2, do an easy one. Convert it to a decimal, 2 goes into 1, can't do it, 0, decimal up here, 2 goes into 10, 5 times, and subtract, so it's 0.5. Turn it into a percent, it's going to be 50%. So let's just turn it into, take the fraction, turn it into a decimal first, and then turn it into a percent. But these are really easy ones, so we all can see it pretty plainly. And the last one, convert the decimal to a fraction. Sorry, convert decimal to a ratio. First, take the decimal, make it into a fraction, like we did back here. Put the decimal to a fraction, and then turn that into a ratio. So, for example, we had 0.5, that will become 5 over 10, or 1 over 2, and the ratio would be 1 to 2. So just convert it to a fraction and convert it into a ratio. So that's basically, the reason why I like that chart a little bit is because it's sort of a summary of pretty much all the fractions and decimals and things we've done so far this semester. So it's good to review the chart. Any questions on that stuff? All good? You guys are a quiet class. No, there are more. You guys are regular attenders, but I think there's actually about 7 or 9. Usually that's on the record. You notice, for example, the more people show up that you don't see when you have tests. It's sometimes random people just show up from nowhere. Yeah. They're the ones that are supposed to be here regularly, but obviously they have better things to do than, just hang out with me for an hour, right? So I don't take it personal, just saying. You got that right. So it's like buying a pair of shoes and not wearing them. Yeah. So they'll figure it out one of these years when they kind of like move on and like, I paid for that course. I didn't pass. That means I got to do it again. I got to pay for it again. What was I thinking last time? It's even worse when you go to university and do it, because here it's about $200. You go there, it's like another $1,000. It's like, oh, ouch. Do that again. All right, so let's do some examples here. Let's copy this page. This is where I usually break into my big lecture about education. Because what I see lots of times, I'll just give you, I'm not going to lecture you guys. You guys are the ones who are here. The worst part about lecturing people is when you lecture the ones that are here, they're the ones that don't need to hear it. That's all right? So looking at converting fractions, decimals, ratios, and percents, this one here gives us a decimal, right here, 0.05. And as a fraction, what would that be as a fraction? Let's look at the place value. So it would be tens, hundreds. So it would be 5 over 100. Everyone see that? And then we're reducing, as far as a fraction, it would be 1 over 20. Because once we have the fraction, the ratio, it's easy, 1 to 20. And as a percent, it's easy, because take this one as a percent, now we go with actually 5%. With the decimal places to the right. So it seems like a lot of different things, but it's not that bad when you really sit down and say, all right, this is how it all fits together. Awesome. You see here, we can go from percent to decimal really easy. And basically, this is a review of the last one, so we can do it again. Actually, the whole thing is what I just did right here. Just realized. All right, let's try something different. This is what I was looking for, actually. Not bad. Let's try a few of these. The first one we have 5 over 8. So this is number 1. 5 over 8, way to get that as a ratio is pretty easy because it's just going to be 5, 8. Awesome. As a decimal, we take the bottom number, 8, that divides into 5. And I won't go in 5, so we put a 0 here and a decimal there. 8 and 50 is what? What number would it be? No multiplication tables now. Just saying that cough that I have is just nasty. I've had that for weeks now. I have to go to the doctor about that. Yeah, that's a good start, actually. Good start because I should show you guys. I learned a trick one time, and it's based on doubles. 8 and 8 is 60. It's 60. It looks for adding and multiplying, and it starts off with the doubles. Then it's double plus 1, double minus 1, and it's really cool for adding or for multiplying. But that's a good place to start. 64. So 8's too high. Take away 8 from that, it's going to be 56, right? That's too high. So then it's down to 6. All right, so that means it's going to be a 6, and this is 48. And I subtract, negative 2, the 0 here, 2 comes right down, or 0 comes down. 8 into 20. Yeah. 2 times, it's going to be 16. I'm going to subtract, negative 4. And I'm throwing another 0 up, 0 down. Now 8 into 40. All right, awesome. So our decimal now is going to be 0.625. And as a percent now is easy because we just moved 2 places to the right. And we have 62.5%. So see what I'm doing? I'm not necessarily doing in order from left to right straight across. I'm doing the way that makes it the easiest to do. So I'm looking at this ratio one right here, and it says 3 to 25. So I'm going to put 3 over 25 over here as my fraction. Into a decimal, number 2. I'm going to take my 25. My pen is acting up again. I thought I'd get through the day without that happening. Sorry, I just lost a thought for a second. When I was in the 30 once, it was easy. I subtract and I get 5. I'm not going through the whole borrowing process because right now we can see that it is 5. Right? So 0 here, 0 pops down. 25 was in twice, and that's going to be 50. And subtracting, we get 0. So as a decimal now, it's going to be 0.12. And as a percent, it's going to be 12%. So now look at the next one. We have 25%. As a decimal, it's going to be 0.25. 0.25 as a fraction. This is number 3. 0.25 as a fraction. Don't start with it. That's equal to 25 over 100, or equal to 1 over 4. So, as a fraction, it's 1 over 4. And as a ratio, it's 1 to 4. And let's look at number 4. Number 4 says we have 0.375. As a percent is going to be 37.5%. As a fraction, it's going to be 375 over what number? 1,000. Yep. Reducing that, $375 should be able to divide by 25. This is 15. And we're not done yet. You don't have to do this one step like I just did. So 15 over 40. You can still reduce that because it ends in 5 and 0. We can reduce it. So 5 into 15 goes 3 times, and 5 into 40. Anyone? 8 times. So as a fraction, it's 3 over 8. Fraction 3 over 8. And as a ratio, it's 3, 8. I was laughing because my son was home. I was like, must be. I was thinking oftentimes when I was a student, like, must be the biggest curse in the world to have a parent who's a teacher. Like, cause there's no way we can't get away from it, right?
Yeah.
I'm not doing this. Yeah, sit down. I'll show you. Ah, really? Yeah. So, no, that's it. So this is combined applications and measurements and conversions, and basically it's a nice way of basically talking about unit conversion. They have a fancy way of saying it. And we've seen it before. For example, height can be measured in feet, inches, meters, centimeters. And everybody know what feet is in inches? We had a discussion already, I think, didn't we? Foot is the size of a foot, and inches the size of my thumb, and that's okay, sounds good. And weight can be measured in pounds, ounces, kilograms, or grams. Don't weigh your weight in grams, because it'll be like 10 million. Don't do that. But if you want to lose weight really fast, take your scales, and take the pounds, turn from pounds to kilograms. You're laughing. That's just too. So I'm like about 180 pounds, 175 pounds. Put on kilograms, I'm about 75 kilograms. Yeah, just rocking the scales. So putting on kilograms, because there's 2.2 pounds in a kilogram, and you basically lose half when you make the conversion. So it's pretty sweet. So, and dosages, and teaspoons, tablespoons, and all kinds of stuff like that. So basically, a couple of things you need to know down here. This is basically pharmaceutical type of abbreviation. The abbreviation for the word drop is GTT. Go figure. But I figure it's the same guy. Both made this up as a guy who's called potassium with a K. I don't know. In the periodic table, right? Just a few of those going on there, right? So that guy was over here too. He said drop GGT or GTT. Perfect. Awesome. See, I get teaspoon, tablespoon, TSB, and TBS. Perfect. And even cup with a C. Don't get dropped at GTT. But that's what they do. So, so it says here, write the word sentence. I don't care about that. No math here. Then we have some standard units of measure. As I said a minute ago, kilogram is 2.2 pounds. In pound, it's 16 ounces. And these are equivalent statements. We see them already. Basically, what I would say of the 1 minute equals 60 seconds. 1 day equals 24 hours, and then you can use them as ratios like I talked before. I'll do some examples, a few examples, and see how it goes. Don't go home and memorize this chart, because like it's a waste of your time. Yeah, it's like, because I'll give you those conversion factors if you need them. So let's have a look at some examples. And you'll see what I mean when I show you this. So we have this is number 2, not 2.27. Number 2. 27 kilograms, how many pounds? So we know that there are 2.2 pounds in 1 kilogram. And that says so right here. 1 kilogram is 2.2 pounds. Okay, so that's our equivalent statement. That means that they are equal. Once you know they're equal, and I want to go into pounds, my unit I'm going into, I want that unit to be on top of my fraction. This is something called dimensional analysis. So when you see it in chemistry, it's called dimensional analysis. Whenever I just knew that though, I was like, dimensional analysis. It sounds really like Darth Vader dimensional analysis. This is going to kill you, like lightsaber stuff. So, but it's not that bad, because basically all I'm doing is making a fraction with pounds on top. So I'm going to have 27 kg multiplied by, if I want to go into pounds, pounds go on top, so I have 2.2 pounds over 1. You'll notice that we've already seen this concept before, and the kilograms will cancel, and it's just multiplied, right? Nothing to see here. So I'll just like calling something different because it sounds like you're doing something different.
I'm looking at the chemistry for next semester, and it seems like there's a lot of that.
Dimensional analysis, yeah.
Yeah, I was looking through, I was like, there's a lot of things.
Yeah, and basically it's all this stuff here as well. It's all this kind of thing. And if you do have trouble with that next semester, feel free to ask me a chemistry question in the morning. And multiply by 2.2, we get 59.4 pounds. See? It's all still. Okay, look at this one here. This one I was looking for exactly. Number 7. $68,000 grams, or how many pounds? Oh, no, let's have a look. So let's look back at our chart here. Looking at our chart, we want to see that excuse me, we have 1 kilogram is 2.2 pounds. Okay, so back further and see what happens. 1 grain, that's not gram, that's just spelled it wrong, that don't work. I don't know, that's all I see. This is chapter 6. 1 kilogram is 2.2 pounds, but I got grams. I don't have kilograms. There's no gram thing here. Oh, man. Stop. What am I going to do? I want to show you this one because this is the one that chemistry is going to look like when you get into the chemistry conversions. So, you know 2 things. One thing we know that we should know right now, that we should know that there's 1,000 grams in 1 kilogram, right? And we also know that there's 2.2 pounds in 1 kilogram, right? So this is how I set this up. And if you're doing chemistry, this is the nice way to go. So we started out with 68,000 grams. I want that unit to cancel. Yeah. So I'm going to use one of these over here. And the only one that has grams in it is the 1,000 grams, 1 kilogram. So I want the 1,000, I want my final answer has to be in pounds, right? So I got to get from here to here somehow. Grams got to go. So if they got to go, I want to use this one here. And grams in the bottom. So 1 kilogram on top. Divided by 1,000 grams. And you'll notice grams are gone. But not the pounds yet. When I get the pound, I need to get rid of the kilogram. So what I do then, take the second one right here, multiply it by 2.2, divided by 1 kg. And you'll notice that kilograms are gone, and the answer is left in pounds. And now for the math part, the big numbers on the bottom, divide, the big numbers on the top, multiply. So for math part, all I got to do is take this 68,000, 68,000, divide by 1,000, multiply by 2.2, and you get 149 pounds. And that is dimensional analysis. When you get to stoichiometry, it's basically all this. Don't let stoichiometry mess you up. It's mostly just changing units, mostly.
And there's like kilopascal and stuff like that.
Yep.
What is a kilopascal?
It's a measurement of pressure. Well, of course, it would be 1,000 pascals, right? So pressure measured in pascals, atmospheres, inches of mercury, and a bunch of pressures. So you have to be able to determine which one you're using, which one you need to use, right? So. And that's it. This chapter. Hopefully this afternoon. So I'll open the tests up and what are you doing right there? Open the test up, I'll give you till Monday to get it done because Mark's not coming on Friday. So as long as you have your test done by Monday, I can actually